Hello, this is the second tutorial on how to generate the values necessary for hypothesis testing. The first tutorial covered how to generate descriptive statistics. This tutorial will now use those descriptive statistics to calculate the t-statistic necessary for hypothesis testing. So once again, we have our tomato example. And our null hypothesis is that the bushel yield of 30 is not significantly different for our new tomato cultivar, in which we have 9 observations, 9 plots where the yield was taken. And we had previously generated our descriptive statistics. So now if we scroll down, we see that we want to calculate our calculated t-statistic. And the formula for that is pretty straightforward. It's our sample mean minus the population mean. Our sample mean, as calculated by our descriptive statistics, was 29.33. The population mean is 30, so that gives us a value of negative 0.67. Our standard error, as was generated for us kindly by the robots, is 0.6. So if we have negative 0.67 divided by 0.6, so the sample mean, subtract the population mean, and then divide that value by the standard error, you get negative 1.12, and that is our t-statistic, and that's the calculated one. Now we ignore the sign because of course we're only concerned about the magnitude of that statistic. So now how do we find the t-tabulated? So that t-tabulated, we could go to the distribution tables and look up n minus 1 and 95% confidence interval. Remember, this is n is our count. How many plots did we have? We had 9 samples, so n equals 9. So n minus 1 plus 95% confidence. So you can go look it up the table, or you can have the robots do it for you. So you select function. So if we go up to here and onto formulas and then insert function, but what we want to do is we want to put it right there. Okay, so we're going to go insert function, and there's all kinds of functions that you can insert. Most recently used, all financial, blah blah blah. So what we want is statistical. And within statistical, we scroll all the way down until you find the t distribution. Now we're doing a t two-tailed, and we want t-inv. We want the inverse of the student's t distribution, and we want it two-tailed. That's the one that we want. So you select OK. And the probability is, well, it's 0.05. 0.05, and that's what you enter into that field. Degrees of freedom, how many? It's n minus 1, so n minus 1 equals 8. You select 8, and it generates the value for you, 2.3. So now we compare our calculated to our tabulated. The magnitude, so the magnitude of our calculated is actually smaller. So 1.12 is smaller than 2.3. We do not reject the null hypothesis. Guess what? 29.33 bushels for the new tomato variety is not significantly different from 30. We can register that tomato variety. So that's how you can do it, using descriptive statistics and by a simple calculation here. And what you can do is you can take this and put it into a formula at the top if you want, or you can do it longhand. But even for the t-tabulated, if you don't want to look it up in the table, you can actually just select that function t.inv.2t, and away you go.